Okay, so back to number 28, the B part, looking for F of the pole that it's putting on the arm of the crane here. We're going to do sum of the forces. Sorry, just move that out of the way so I can get my paper. So we're going to do sum of the forces, so we could start with sum of the forces in the x direction. This whole system is not moving in the x direction, so MAX will be 0. So there's FPX pushing outward, and there's FTX pulling in. So FPX is equal to FTX, and FTX is just going to be FT cos theta. We just found the FT, so FPX is going to be 8582.28 newtons times the cos of 32. So FPX will equal 7,278.19 newtons. So that's my FPX. Now I'm going to do my FP, sum of the forces in the y direction to get my FPY. Goes to 0. So going up, we think, is FPY. Going up, we think, is FTY, we know. Going down, FG of the arm and FG of the crane. It's a minus. Solving for FPY, taking the other ones over, it becomes M of the arm G plus M of the crane G minus FT sine theta. So FPY equals 345 kilograms. I'm going to cheat and do plus 355 kilograms times 9.81. I trust you can all handle that. Minus the 8582.28 newtons sine of 32. And when you do this, I hope that's okay that I put those together, is equal to 2,319.08 newtons. It's a bit bigger than our FPYs have been in the past, but that's because the container's not all the way out on the end. It's in further, which means the house needs to, or the pole needs to support it more. So now we do like what we've always done. We draw our X, 7278.19 newtons. We draw our Y, 2319.08 newtons, square them, add them together, take the square root, and find FP is equal to 7638.75 newtons at an angle of 17.67 degrees, and that of course would be CCW arm. Okay, so that's part B. All right, the other question that I asked you to do was number 5 on the back side of your sheet from the more torque questions. Okay, so number 5 is Sir Lancelot, King Arthur and the Knights at the Round Table. You know Sir Lancelot? Okay, so it is a ladder leaning against a building. It says the ladder is uniform, so that means FG of the ladder is going to be smack dab in the middle. Lancelot is trying to rescue Lady Elaine. The ladder is 5 meters long. And the ladder weighs, so FG of the ladder is 180 newtons. Lancelot, who weighs, okay, I'm going to call Lancelot a person because otherwise I'm going to have too many L's here, weighs 800 newtons. Stops a third of the way up, so Lancelot's R is just 1/3 of 5 meters. Okay? The ladder is resting on a horizontal stone ledge against a vertical wall, frictionless. The angle, it looks like I gave you an angle. Did I really just make it 53.1? It's really supposed to be 53.13, of course. Find the normal and frictional forces at the base of the ladder. So you're looking for F normal of the ground, and F, friction of the ground. Lancelot's thing is here. This is FG of the person. And coming out here, of course, is F normal of the house. Okay, so first we could do some of the forces in the y direction going to 0. There will be an F normal of the ground minus FG of the ladder minus FG of the person, Lancelot. So normal of the ground will just equal FG of the ladder plus FG of Lancelot, which they gave us. So it's just equal to 180 newtons plus 800 newtons. F normal of the ground is equal to 980 newtons, which is one of the things they asked us to find. The second thing they asked us to find was FFR of the ground. If we do some of the forces in the x direction, it's going to be 0, and there are only 2. So F normal of the house minus friction on the ground will equal 0. So normal of the house is equal to friction on the ground. So if we can find normal of the house, we'll get our friction on the ground. And of course, we're going to find that by doing some of the torques. So some of the torques will equal 0. Normal on the ground, friction on the ground, normal of the house, ladder, and person. If we pick our pivot point here, which I highly recommend, then this goes to 0, this goes to 0. This will be positive, negative, negative. So it'll be R normal of the house, F normal of the house, sine theta normal of the house, minus R of the ladder, FG of the ladder, sine theta of the ladder, minus R of the person, FG of the person, sine theta of the person. Okay, we're trying to find Fn, so take the other two terms over. R of the ladder, M of the ladder, G. Oh, actually, I could just leave it as FG because they gave us that, sorry, of the ladder. Sine theta of the ladder, plus R of the person, FG of the person, sine theta of the person, divided by R normal of the house, sine theta normal of the house. All right, so what is the R of the ladder? Well, it's a 5 meter long uniform ladder, so that means the center of mass is acting halfway along its length at 2.5 meters, not kilograms. Okay, FG of the ladder, they gave us as 180 newtons. Sine, the angle between the R and the F is right here, and so it's going to be 36.9, really 87, but I'm trying to cope. And then R of Lancelot, whoops, this one was the ladder, this one was Lancelot. He's 1/3 of the way up, so 5 over 3 meters times 800 newtons. And Lancelot's angle is going to be the same as the ladder, 36.9. Normal of the house is going to be the full, R of that is going to be the full length. Sine, and this time the angle between the R and the F is this one, which is the same as the base, so 53.1. F normal of the house. When you do this, you should get 267.79 newtons. Okay, so there's the two answers to part A. Part B wants to know what's the coefficient of friction. So we know FFR of the ground is equal to mu Fn of the ground. Oh, by the way, this is your friction on the ground, because remember earlier we said they were equal. So we're looking for mu of the ground. It's going to be equal to friction on the ground divided by the normal of the ground. Friction on the ground is 267.79 newtons. Normal on the ground is 980 newtons. Shoot, I'm going to run out of time. The next one is really not that difficult. It wants to know what's the force. So you found F normal of the ground is an x component. Friction on the ground is your y component.